Okay, so good afternoon, everyone. So today, please help me to make recordings. Okay. So today we continue to study the linear algebra, and we hope we can finish lecture 1, part 3 today. And of course, we will have the homework of this lecture. So remember that we have the homework when we finish every lecture. Okay, so because we haven't finished yet lecture 1 part 3, so we don't have the homework. Okay, yeah, for this lecture. So for today, when we finish these lectures, I will give you the homework, okay, of lecture 1 part 3, and then we continue to study lecture 1 part 4. Okay, so remember that totally we have 16 class, okay, for this course. Okay, and now this is the 7th class. Okay, yeah, and we hope we will finish the course, okay, before 7 February 2026. Okay, yeah, so anyway, we will finish before that day. Okay, 7th of February 2026. Okay, so if someone are going to book the flight tickets, okay, to go back your hometown, okay, remember you need to book the flight tickets, okay, after that day. Okay, otherwise you will miss some classes, and then if TA check your attendance, then you cut class. Okay, yeah, you violate the which use your exam regulation, and then you cannot take the final exams. Okay, remember that. Okay, this is the final date to finish the course. Okay, of course, for linear algebra and physics 1. Okay, so we review a little bit, okay, the content of lecture 1 part 3 we studied last week. So we discussed about inverse matrix, right? Inverse matrix. Okay, so if we have matrix A, we would like to determine inverse of A. Okay, this one is inverse of A. So we need to arrange A and then matrix I. Okay, and then we apply Gauss-Jordan elimination. Okay, Jordan elimination, you can get I and inverse of I, or you can say here this is left matrix. Okay, and this one is right matrix. Okay, so when we apply Gaussian Jordan elimination, okay, left matrix becomes identity matrix, and the right matrix will becomes inverse of A. Okay, inverse matrix. So for more general, if we have A with m rows and n column, okay, we would like to figure out inverse of A. How can we do? So we add the identity matrix, okay, m rows and n columns. Here we have I, yeah, we have the same rows and n columns and m columns. Okay. But actually, when we calculate the inverse of the matrix, A must be square matrix. Okay, yeah, so A mm m and m, and this one we have m rows and m columns. Okay, so here we can guess m rows and 2m columns. Okay, after that we apply Gauss-Jordan elimination. You can get I, m, and m, and here is inverse of A. Okay, so this is the ideas. This is the method to determine the inverse of the matrix. Okay, so come back the lectures. So now, and then we also we study how to determine the solution of linear systems. For example, we have A, right? Matrix A times X is B. Okay. Yeah, so this is the general formulas of linear systems. Okay. So if we times inverse of A at the left side, okay, at the left term, okay, and inverse of A to the right term. Remember, we need to follow the law, you know. I mean, here is left multiplication, right? Okay, so here should be left multiplication. Okay, so inverse of A times A, you can guess I times X equal to inverse of A times B. Okay, I times X is what? Is X. So X is inverse of A times B. So if we already get inverse of A, we times B. What does this mean B? B is a constant, right? Constant term. Okay, matrix. Okay, and then we apply inverse of A times B, you can get the solution. Okay, yeah, this is the second method. So the first method, you can use Gaussian elimination. Okay, so if we apply directly Gaussian, okay, elimination and back substitution. Okay, by substitution, we also get X. Okay, so this one is the first method, and this is the second method. Okay, so it's up to you. Okay, so it depends on these exam questions. Okay, so sometimes I ask you to calculate determinant. Sorry, to inverse of A. Okay, and then we after that we calculate. We look for the solution, or we just apply directly Gaussian elimination and by substitution to get the solution. Okay, so it depends on the requirement of the exam questions. Okay, so now we continue. Yeah, so look at this one. We have the linear systems. Okay, AX equal B. Okay, so if we have A, so we can calculate inverse of A, and then we can get the solution X. Okay, this is the matrix, you know. X is inverse of A times B. Okay, yeah. So look, if A is an invertible matrix, then the system of linear equation AX equal B has a unique solution. X is inverse of A times B. Okay. And we also have some examples, right? Okay. Yeah. We have the properties of inverse. Okay. Yeah. So if B and C are both inverse of the matrix A, okay, then B equal to C. Okay. So A times inverse of A or inverse of A times A is identity matrix. Okay. Yeah. And you should remember A must be a square matrix. Okay, must be a square matrix when we determine inverse of A. Okay. It doesn't mean any square matrix will have its inverse matrix. No. Okay. But it is a square matrix is the initial condition. Okay. In the first condition to have you whether determine the inverse matrix or not. Okay. Yeah. So we have the matrix. Okay, this is a square matrix, right? A is A, B, C, D. Okay, that means we have 2 times 2. Yeah. So we can get inverse of A. Okay, directly by using this formula. Okay, we don't need to apply AI become I inverse of A. You know, we just apply the formula if you remember that. Okay. Well, here we have 1 divided by A times D minus B times C. Okay, and then times the matrix D, because we already know A, B, C, D, so you can get D minus B minus C and A. Okay, but for my experience, this one just for your reference, because when we apply this methods, okay, it will be convenient. Okay, yeah, and you don't need to remember these formulas, okay, in your mind. Okay, you just apply the general solution. We can get the inverse of A. Okay, you just get it for your reference and skip it. Okay, so now, for example, we would like to determine whether the matrix is invertible or not. Okay, yeah, of course, A is square matrix. Okay, here is also a square matrix, but we don't know. We can find inverse of A or not. Okay, so we apply the formula, right? We have AI. Okay, and then we would like to modify AI become I inverse of A. So here we have A is 6, 1, right? 5, 2, and we need identity matrix 1, 0, 0, 1. Okay, yeah. So this is row 1, this is row 2. Yeah. So we think about we times 1 over 6 with R1 related to R1. You can get what? 1 over 6, 1 over 6 and 0. Okay, and this one is 5, 2, 0, 1. Okay. Then we would like to delete 5. So that means we time minus 5 with R1 plus R2, right? Replace into R2. This one is the third rule of elementary operation, right? So here you can get 1, 1 over 6, 1 over 6, 0. And then you can get 0, right? Because here is minus 5, right? And here you get minus 5 over 6. Here is also minus 5 over 6. This is 0. So minus 5 over 6, okay, plus 2, okay, minus 5 over 6 plus 2, that means 10 over 6, right? Right? So we can get 7 over 6, okay? So if I have some mistakes, please remind me, okay? And here is minus 5 over 6 plus 0, so you get minus 5 over 6, and this one is 1, okay? Yeah. Then continue, we need to modify this one to become 0, right? Yeah. This one becomes 0, right? So here it must be 1, okay? So maybe I write here. So you get a 1 or 1 over 6, 1 over 6, 0. And this is 0, this one is 1. That means we need to times 6 over 7 times R2 related to R2. Okay, so you get here is 1, and 6 over 7, and here we have minus 5 over 6. Okay, so you can get minus 5 over 7, right? And then here you get 6 over 7. Okay, yeah. Okay, now we would like to do this one to become 0. Okay, so that means we time minus 1 over 6 with R2 plus R1 related to R1. Okay, so here you get 0, 1 minus 5 over 7. This one is 6 over 7. Then you get 1, right? And the minus, okay, if we times, so minus 1 over 6 here, minus 1 over 6, and minus 5, 7, and then we times for minus 1 over 6. Okay, so you get how many? You get 5 over 72. Okay, and now we have 6 over 7 times minus 1 over 6. You get minus 1 over 7. Okay, so here you get 0, and here you have 5 over 42 plus 1 over 6. Okay, that means 7 over 42. Okay, so you get 17 over 42. Okay, so you get how many? You get divided by 6, you get 2 over 7, right? 2 over 7, 2 over 7. Okay, 2 over 7, and here you get minus 1 over 7, but 0 you get minus 1 over 7. Okay, so this one is I, and this one is 4 inverse of I. Okay, so finally you get inverse of I, 2 over 7 minus 1 over 7 minus 5 over 7 and 6 over 7. Okay, let me see here. Okay, correct. Yeah, so yeah, this is just examples how to determine inverse of H. Okay, any questions so far? If you have any question, you can type the message to the chat room, or you can ask a TA, and then TA will repeat to me. Okay. TAs, are there any questions for the class? Okay, maybe I go back to check whether we have any question or not. Okay. 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 So continue. Okay, so for and then similarly we can calculate this inverse of I. Okay, but now for this matrix, okay, you can analyze the matrix here, okay, to become this is minus 1, this is 3, this is 2, this is minus 6. Okay, so if you observe this matrix, we say this one is R1 and this one is R2. Okay, so that means if we times minus 3 with R1, they will become R2. Okay, right? So you have minus 3 with minus 1 and 2, you can get 3 and 6. 3 and minus 6. Okay, so that means R1 and R2 are dependent. Okay, are linearly dependent, right? Dependent. So if some columns or some rows are linearly dependent, you can say that we cannot get inverse of I. Okay, because sum of rows or sum of columns are linearly dependent. Okay, it's not good, and then you cannot find inverse of A. Okay, yeah. So this is the tip for you. So later on we have some properties talking about that. Okay. But you can remember if are there any linearly dependence of some rows or some columns of the matrix A, we can conclude directly we cannot find inverse of A. Okay. So and then we have the other properties. Okay, we have A times B totally inverse equal to inverse of B times inverse of A. Okay, yeah. We need to take this inverse of individual matrix and then we change the sequence. Okay, the function here A to B, and when we take the inverse, you can get inverse of B times inverse of A. Okay, yeah. Okay. We can demonstrate how can we get this one. Okay, now look at this one. We can establish the invertibility and obtain the stated formula at the same time. So here, we just pick up inverse of B times inverse of A. Okay, inverse of B times inverse of B times inverse of A. So if I times B and I times A and B here. Okay, that means left multiplication. Okay, so we can get what? So here we have a B and inverse of B. You can get I. Okay, I times A times inverse of A. So A times I is A and inverse of Y. So A times inverse of A is I. Okay. So here we times AB with AB inverse of Y. Okay. So so here I say AB, and you know A times B is inverse 1. So if we say inverse of A and inverse of B, you are wrong because we cannot simplify. So if we assume this term is correct, so that means you can get A times B, and this is inverse of B, and this one is inverse of A, and this one you get I. So that means we have demonstrated this term. Okay. So here is the description. So a product of any numbers of invertible matrices is invertible, and the inverse of the product is the product of the inverse. Okay, the inverse of the product. Okay, the inverse of the product is the product of the inverse. Okay, product of the inverse. Okay, in reverse orders. So that means A times B totally inverse is inverse of B times B inverse of A. Okay, yeah. And this property is very important, and we can apply this property for other lectures. I hope you enjoy it. Any questions so far? Okay, continue. Now, this is examples, but I think it's easy. Okay, so we have A, B. So we first of all we calculate A times B, and then we calculate inverse of A times B. So A times B is 7698. So inverse of A times B you get here. Okay, or you can from A you can calculate inverse of A, from B you can calculate inverse of B, and then you take inverse of B times inverse of A, you can get the same result with this one. Okay, yeah. So inverse of B is here, inverse of A is here. So inverse of B times inverse of A is this one times this one. You can get this one and this one. Okay, they are the same. Okay, yeah, so we already demonstrate the properties we discussed before. Okay, we have powers of a matrix. Okay, look, A to the power of 0 is identity matrix. Okay, so A to the power of n, that means we have n factors of A. So that means A times A blah 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 times A. So we have n factors. Okay, yeah. For example, A to the power of 3, that means A times A times A. Okay, yeah. So we have A to the power of minus n. Okay, yeah. A to the power of minus n is A to the power of minus 1 times n. So what is this? This is inverse, right? This is inverse of the matrix. Okay, yeah. So and then we take the power of A. So that's mean inverse of A times inverse of A blah 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 times inverse of A. We have n factors. We have n factors. Okay, yeah. And next one, we have A to the power of R, A to the power of n. So we can get A to the power of R plus S, very easy, you know. So yeah, we summarize here. If A is invertibles and n is non-negative integers, and that means positive, n must be positive integers. Okay, so inverse of A is invertible and we take double inverse, right? Double inverse of A, you can get A. Okay, we take inverse of A and inverse of A again, you can get A. Okay, and this one we discussed before. Okay, so Ka is invertible for any non-zero scalar K. Okay, so we have K times A totally inverse is inverse of K and inverse of A. Okay, K to the power of 1. Okay, yeah, K to the power of 1 is, of course, this is 1 over K inverse of A. Okay, yeah, this is matrix. For example here, okay, we have A and inverse of A. Okay, we would like to calculate A to the power of minus 3. That means is inverse of A to the power of 3. That means inverse of A times inverse of A times inverse of A. Okay, here, you can get this one. How can we calculate this one? You know, it's very easy. You know, we can take this matrix times this matrix first. Okay, this row and these columns, you can get how many? 3 and 3, 9 plus, so you get 11. Okay, and this one times this one, you get minus 3, right? Minus 3 is minus 1, you get minus 4. Okay, here you times this row times this column, you get a minus 6, minus 2, you get minus 8, and then this one times this one, you get 2 plus 1, you get 3, and then you multiply one more matrix. Okay, 3 minus 2 minus 1 1. Okay, so you can get what this is 33, and then A you can get 41. Okay, this one times this one, we can get how many? Minus 12, minus 2, minus 15. This one times this one, you get minus 22, minus A you get minus 30, and this one is 8, A plus 2 11. Okay, so we can get this result here. Okay. Anyway, you need to practice, okay, by doing exercise, okay, and you can understand more. And yeah, we can calculate inverse, or we can calculate A to the power of 3, and then you take inverse. That's okay. That's okay. So A to the power of 3, that means A times A times A. You can get this one, and then you take the inverse of A to the power of 3. Okay, you can get the same result. Okay, it's up to you. Now we discuss the square of a matrix. Okay, so if we consider real arithmetic, that means A is a real number, B is a real number, not a matrix, you know. So A plus B totally square is A square plus AB plus BA plus B square. Okay, so you get A squared plus 2AB plus B squared. But if we have matrix arithmetic, okay, so if we have matrix arithmetic, we cannot do that. Okay, so we need to keep, because A times B, matrix A times B will be different, yeah, B times A, okay, excluding some typical cases. Okay, so here we have A plus B totally square is A square plus AB plus BA plus B square, because normally A times B is different from B times A. Okay, but we have some special case. Okay, so if A and B commute, A and B commute, what does this mean? Commutation. Okay, commutation. Commutations means A times B is equal to B times A. Okay, we have some special cases. A times B is equal to B times A. Okay, so that means A equal to B. So you can get this one. Okay, A plus B totally squared is A squared plus 2AB plus B squared. Okay, yeah. So in general, I think you should remember this one for the squares of the matrix. That's okay. Any questions so far? Let me check. Any questions? Okay, no. Then, yeah, I say no commutative law. No commutative law. That means A times B difference, B times A in general. Okay, so we have more properties of transpose. Okay, we talk about the transpose. Of course, we know transpose of A. So if we have A with m rows and n columns, so the transpose of A, the transpose of A, the transpose of A will be n rows and m column. Okay, yeah. So we have double transpose of A is A. Okay, transpose of the sum E, the sum of the transpose. Okay, and this is subtraction, a scalar multiplication. You know, a scalar multiplication, K times A totally transpose is K times transpose of A. And then look this one. So we have A times B transpose E, transpose of B, and transpose of A. Okay, yeah. So this one for the properties of the transpose. Okay, so for the final exams, you can use digit. Okay, you can use digit. I don't remember one or two digits. It depends on the final decisions. Okay, in the revision class, the final class, I will tell you how many digits you can carry into the exam room. Okay, and then you can add any properties you want. Okay, into your digit. Okay, yeah. Now, this is interesting properties. Okay, if A is invertible matrix, A is invertible matrix, that means A is a square matrix, of course. Okay, yes. So then, transpose of A is also invertible. Okay. Or you can say A, the transpose of A, and then you take the inverse. A is the inverse of A, and then you take transpose. Okay, the same. Okay, so please remember this properties, very important. Okay, very important. So we can demonstrate. Okay, so if we times transpose of A here, okay, and then you assume this one is correct. So transpose of A times transpose of A to the inverse. What is 6? This one is the properties of the inverse, right? The properties of the inverse, right? So if we say BE transpose of A, so now this one become B and inverse of B, right? And this one become identities. Okay, this is the properties of the inverse properties. Okay, of inverse. Okay, so now um, we think about for the we accept this one, so we have transpose of A, so the transpose of A to the inverse of transpose of A is equal to the inverse of A, and then you take transpose. Okay, this one, okay, yeah. So here this is transpose, so you get A and inverse of A totally transpose. Sorry, should be like this. Okay, we apply the properties of the transpose, so this is inverse of A and A, right? Yeah, the products of individual matrix transpose is the transpose of the products. Okay, here, where, here. Okay, yeah, and now if we apply the same properties of the inverse, this one become I. Okay, so here you get I to the transpose, so the transpose of I, right, is I. Okay, yeah, so I demonstrate this one. Yeah, so here, here, so this one equal, right? This is equation one, this is equation two. Okay, so equation one, we hold a transpose of A times blah 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 equal to one, and here equal to one. That means this one equal to this one. Okay, that means A times B equal B, B times A. So that means we get inverse of A to the power to the transpose. Transpose of inverse of A is the transpose of A take inverse. Okay, so here I demonstrate to you. Okay, so I already demonstrated about this property to you, or you just remember the formulas. Okay, that's okay. Okay, and then we have this one just example to let you more understand about these properties. The transpose of A, the inverse of the transpose of A is the transpose of the inverse of A. Okay, and then samples of exam questions. Okay, so for the exams, I will ask you some kind of questions like this. Okay, so find the inverse of the matrices. Okay, if they exist. Okay, of course this is square matrix. This is square matrix. This is square matrix. This is also square matrix. So we need to apply I to become IA, right? Yeah. AI to, and then we apply Gauss, Jordan, okay, elimination. Okay, yeah, you can get the result. Very easy. Okay, yeah. Or I've asked you to determine the inverse of the matrix. The inverse of the matrix. Okay, so when you get the inverse of the matrix, you can get, you continue to calculate the solution. Okay, and they solve the linear system. That means, first of all, you need to calculate inverse of A, and then you calculate the solution, okay, of the linear systems. Okay, yeah. For example, we consider this one. Okay, So we can guess A is what? A times X equal B. So A is what? A is 1, 2, 1 minus 2, right? And X is X and Y, right? And B is minus 1 and 3. Okay. Yeah, of course, this one is A. This one is X and this one is B. Okay. So we need to calculate inverse of A. So you get 1, 2, 1 minus 2, 1, 0, 0, 1. Right? This is A. This one is I. And then we can try to guess I and inverse of A. Okay. So this is R1. This is R2. Okay. So here you can get 1, 2, 1, 0. Right? And if I take the minus R2 plus R1 replace to R1. Sorry. Minus, minus R1 plus R2 replace to R2. Okay. So here you can get minus 1, minus 2, minus 1, 0. Okay. Plus R2. So you get here is 0. It's minus 4. Here's minus 1. Right? Here is 1. Okay. Then continue. Okay. So here 1, 2, 1, 0. And here I say 0, 1. That means 1 over 4. This is minus 1 over 4. All right. Okay. And I would like to modify this one. So we apply the formula, right? We have minus 2 R2 plus R1 related to R1. So you can get 0, 1, 1 over 4 minus 1 over 4, right? And then if we times minus 2 here, and here you can get minus 1 over 2. This one is 1 over 2. This one is 0. 1 minus 2 plus 1, you get 1 over 2, right? And here you get 1 over 2. Okay. So this one is I, and this one is inverse of I. Are there any mistakes? Let me check. Minus 2, minus 1 over 2, 1 over 2. Okay, I hope I am correct. Okay, because I calculate so fast. Okay, so here you get inverse of H, and then you can get X. So X is now 1 over 2, 1 over 2, 1 over 4 minus 1 over 4 times this inverse of I. And B is minus 1 and 3. So you can get the answer, right? Minus 1 over 2 times minus 1, you get minus 1 over 2, right? And then this minus 1 over 2 plus 3, you get 3 over 2. Okay, so finally you get 1. Okay, and then you get minus 4, minus 1 over 4, and minus 3 over 4, so you get minus 4, you get minus 1, so you get the answer, right? You get X is 1 and Y is minus 1. Is that correct? This is 1, this is minus 1, so you get minus 1, right? Because 1 minus 2 minus 1. This is 1, this is minus 1. Minus 1 times minus 2, 2, so plus 1, you get 3. Okay, correct. So, anyway, yeah, just example, and if you make familiar with determination of inverse of I's and get the solution to the systems, okay, you can get maybe 10% for the final exams. 10% score for the final exam. It's minus inverse of I. Okay, any questions so far? Today, are there any questions for the class? Okay, so if no questions, we continue. Okay, yeah, I think it's easy for you to follow the lectures today, right? Okay, so for exercise, we finish. Okay, lecture 1, part 3, and of course we have homework. So for the homework will be exercise. Let me see. The homework will be exercise 5, 6, 7, 8. Okay. So we have homework. This one is homework. Okay, homework 1. Okay, this one. Okay, we have A, B, C, D, and we need to verify this one here. Homework 1, and this one is homework 2. Okay, homework number 2. Okay, yeah, 5A. Okay. So for x in the equation given here, so we know A, we know B, but we don't know x. Okay, we need to calculate x. So for x in the equation given here, x, just practice, you know. So how about this one? Very easy, right? To compute the inverse of the matrix, very easy because they are 2 rows and 2 columns, so very quickly you can get results. Okay, this one just demonstrate. Okay, just a demonstration. Okay, here you to find A, you know, to find A. So we have, for example, here we know 7A to the inverse. Okay, that means we have 7 inverse and A inverse. So 7 to the power of minus 1 is 1 over 7 times inverse of A. Okay, is minus 3, 7, 1 minus 2. Okay, so if I modify this one, 1 over 7, so inside we can get minus 3 over 7. No, we get what? We get what? So if we take the, I try to modify this one. Okay, so if we take 1 over 7 here, so here you get minus 21. This is 1. This one how many? 7, right? Anyway, we just divide this by 7 times, yeah, we take the 1 over 7 here, so that means you need to times 7, so you get here is 40 or 40, 49, right? And this one is 7, this one is minus 14. Okay, so this one is inverse of A. Okay, yeah. So when we take the inverse of A and inverse, you can get A. So now we know here is inverse of A. Do you understand? Because if we apply the formulas, we have K inverse K, right? K times A, K times A totally inverse A, inverse of K and inverse of A. Inverse of K is 1 over K times inverse of A. Okay. Yeah, or if I assume A we have A, B, C, D. Okay, that means you can get A over K, right? B over K, C over K, D over K. Okay, so here this is the result. Okay, minus 3, 7, 1, minus 2. I would like to modify become 1 over K times inverse of A. Okay, yeah, so to try to get this one, right? If I take 1 over 7 outside here, you get minus 21. because 1/7 times minus 21, you get minus 3. And this is 49, this is 7, and this one is minus 14. Minus 14. So this one is 1/7, and here must be the inverse of a. Okay, so when we get the inverse of a, you take the inverse of a, you get a. Okay. So then here, here we have the transpose of a, and then minus 1. That means you get right, you get the inverse of a, and then you take transpose like this one here. Transpose of a to the power minus 1 is this inverse of a times transpose of the inverse of a. Okay, so here like this. Okay, transpose of a take the inverse here, inverse of a times transpose equal to oh, here we have 5, we have 5. Yeah, so for here we don't have for more space. Okay, maybe I will copy it. Okay, and move to here. Okay, continue. So we have 5 transpose of a times to the power of minus 1. Okay, yeah. So here, look, so you get 5 inverse of 5 and transpose of a inverse, right? So inverse of 5 e 1/5, 5 to the power of minus 1 is 1/5, right? And then we have transpose of a. Okay, transpose of a to the power of minus 1. Okay, yeah. That means inverse of a to the transpose. Okay, transpose of inverse by equal to minus 3, 5, 1, minus 1, 2. Okay, yeah. So we need to take it is 1/5. So here we can get minus 15 minus 5, because we times 5 and you get 25, you get 10, right? Minus 15 is 5, you get minus 3. Minus 5, minus 5, you get minus 1. This is 25. If I have some problem, some mistakes, you let me know. Okay, so now we can say that the inverse of a transpose is minus 15, minus 5, 25, 10. Okay. Okay, so I would like to delete transpose. So inverse of a is 1. Okay, so if row becomes column, you get minus 15, minus 5. The first row become the first column. The second row become the second column. So you get 25 tenths. Okay. Yes. So now we can get inverse of a, and then you take the inverse of a. You can get a. Okay. Yeah. So that means you can get a minus 15, minus 5, 25, and 10 inverse. Okay, so you can get a. Okay, and then so on, yeah. Okay, so yeah. And we have homework 7 and homework 8. Okay. Let me see. So we have some exercise. Let me check. Okay, I think that's enough. That's enough. Okay, so this is homework 1, homework 2, homework 3. Okay, very easy, you know, just verify. Okay, so that's B is E the inverse of A. That means you need to demonstrate B is E the inverse of A. We need to calculate inverse of A. Okay, homework 4. Okay, we calculate, yeah. Okay, so finish lecture 1, part 3. Any questions so far? So anyway, the homework of lecture 1, part 3 will be exercise 5, 6, 7, 8. Okay, and you need to submit maybe uh, next 2 weeks. Okay, I will set up the deadline for you. Okay. Okay, so, any questions so far? So if you have no question, we take a break, and then we will come back at 2:10, and you will come back at 2:20. Okay.